Okay, perfect. So hi everybody from my side as well. Thank you already for the nice words by both Nikos with 1 and 2 C's. My name is Tim Raj and I was the work package lead for work package 3 over the last roughly 2 years. And I'll be now sharing a little bit of more content about the labeling, geometries and the methods. Overall, I will focus mainly on 3 topics because we have not that much time, but I will quickly speak about our process towards a joint consensus. So how we analyzed where we currently are and where we actually want to be. Second, I'll be talking about actually how we incorporated best practices from an engineering perspective to making the life of the people who actually use the standard in the end as easy as possible and to be able to share the data. And third, I will be speaking about the different annotation types, which we are covered in the initial release version 1.0. So overall, our joint consensus started actually with exploring what is currently the industry demand. And I think this is actually quite unique for the standard because with ASAM, we had quite a broad member base from both OEMs, tier 1 software suppliers, annotation companies. So we were able to actually have a look on the whole topic of data annotation, how to make it scalable, what is actually needed from a variety of perspectives. And I think that in the end, the standard has the ability to basically fill an important role that touches all of the previous types of companies which I have described before. And I think I speak for all the people involved that even though we worked in this space for quite some time now, even the people who were now involved were surprised how many different facets and how many different options people can actually have on the topic of labeling and how it is actually lived within the companies. And what we then actually found out that the demand is actually far greater than what we can achieve in the first version of this standard. So what was very clear after syncing and getting all the different perspectives that we need for this first iteration define certain focus areas. But given the fact that we had now a very broad overview over all the different needs and demands, like not only what they currently need, but what might be expected in the future, we were actually able to shape the standard in a form that allows it to be extendable in the future versions. And we will see in a minute, for example, what types of annotation are actually included in this version and which we did not touch upon, but which can be added in later versions. And obviously in the third point, we then had to identify a joint consensus, not only for the annotation types, but as well for underlying constructs such as how can we represent certain spatial rotations, how can we identify the definition of the coordinate systems, and obviously a lot of the format options, which Marcos will be talking about. And so broadly speaking about what is actually covered now in this first iteration, we specifically took a look at what is currently creating the most work or what is currently the majority of the market. And this in the end will be there are several variations of the 2D bounding boxes, the same of 3D bounding boxes as well called cuboids, obviously, several types of semantic segmentations, which can later be extended as well, and point cloud segmentation. But from our experience and inputs, we saw that this is currently growing, but still an important topic. Speaking now a little bit about the best practices from an engineering perspective. And what we as well identified talking to a lot of engineers from different companies is that not only coordinate systems are actually used in very different formats and options throughout the companies, but this really increases a real big issue for ensuring the compatibility, sharing the data not only within the company, but as well between different stakeholders. And we then really try to incorporate, as we can see here on the left side, how we define our coordinate systems being compliant with other standards, having included the best practices. And on the right side, if we think about how we rotate, for example, 3D cuboids, obviously a lot of people resort to Euler angles. However, what we as well saw, if you actually talk with a lot of the engineers and what they need for a daily work, quaternions pose a very comfortable and I would say yeah, it's basically very comfortable to work with them. It's not that error prone as, for example, job patrol. And so we try to focus the standard on this, but what we saw in the end was that we need to represent Euler angle as well. So basically what you can not only expect from the standard is having a solution, but basically having a lot of the best practices with a lot of stakeholders from different companies share the vision that this should actually be implemented to make their work lives actually a lot easier. And speaking now a little bit about the annotation types, which we actually covered. So we initially started actually with the 2D bounding box, and we started with defining all the different annotation types with all the stakeholders. And we even identified that such basic topics such as what is actually considered a bounding box can have very different interpretations. And I think this is a very good knowledge base as well for other people if you want to take a look at what can be defined and how it should be defined. You will find this here in the standard. And I think one of the first learnings actually is that we do not need to have our regular 2D bounding boxes, but we as well need to be able to incorporate rotated 2D bounding boxes. We were able to do that. And this, I think, speaks for all the different annotation types as well. And so we obviously have the same topic here for the 3D bounding boxes, where we have tried to define it and make it as user-friendly as possible. And what we as well identified when we were talking about semantic segmentation, that actually there's a broader divergence on the market than we expected for other annotation types, such as 2D bounding boxes. And in the end, we decided to focus this initial release on basically 4 topics: on partial scene segmentation, full scene segmentation, single class per pixel segmentation, and multi-class per pixel segmentation, which basically allows us to grasp the initial momentum which is currently used. And here we can see actually a very representative scene. So we see several cars interacting. You can see the white van, you can see the black car, you can see a more, I think it's more like a grayish color on the right, but you can as well see a lot of scenery around it. You can see the different vegetation, you can see the poles, you can see the street. And obviously what we tried, and I think this is very well reflected in the joint format, is that you can have actually all different representations that you want, which are coherent in the end. So you can have only a partial scene where you actually just look, for example, in this case for the vehicles. You can have actually the same view, obviously, but represented with different instances. So we can see this on the bottom, where each color represents their single instance. You can have it actually in the full scene version, where you represent all the different classes at once. And if you want a combination of a full scene and the instance awareness, you can obviously have this as well in our standard. And the same obviously counts for the point cloud segmentation, which we have incorporated here as well. I think this was a very quick and brief overview over the annotation types. And if any one of you is currently missing an annotation type, an example would be, for example, point annotations or skeleton annotations. These are all things which we realized will actually be needed by the industry, but they are currently accounting for a smaller portion of the market. And the same goes actually for segmentation types, where you assign for a single pixel in a 2D image several classes as well as several instances, where you use layering approaches to basically even incorporate different versions from an image. And these are exactly topics which we want to focus now in the forthcoming versions of the standard. And another important topic where we see a lot of potential as well for forthcoming topics will be the quality assurance topic, where we already have found out that there's actually quite a big divergence in the market. So what is actually defined quality? How can we measure it? How can we incorporate it? Yeah. So thank you. And now I'm handing over to Marcos for the format view on this topic.